Hello everyone. In the last class we have discussed about the introduction of electrostatic potential. So in the chapter 2 we have discussed introduction. So in this class we are going to discuss about potential energy in an external field. So we know the definition of potential in the last class we have discussed. When you take the charge from infinity to that point, I can say work done. So here I have taken uniform electric field. So under charge I can take from point infinity to this point. Then the distance is r vector. So here you can see we have to solve the definition and we have to take we have to find the expression for potential. So that is for a single charge. If single charge is there, what is the potential? So we know the potential formula, that is V of R. So that V of R, W, then I can say work is done. When work is done, we have to take the charge from infinity to this point, means work is done by applying the external field, that is W is equal to Q into V of R. Then the potential energy of Q at the distance R to this particular point from the external field, that is U is equal to Q into V of R. So this is the expression for potential energy in an external field. And the next is potential energy in an external field by applying the external electric field for two charges. So here you can see in this diagram we have to take two charges, that is potential energy in an external field for a system of two charges. So here we know the formula of work done by against the external field, that is work done is equal to Q into V of R in the last slide. So in this slide we have to take two charges. Two charges means I can say work is done with the charge 1 and work is done with the charge 2. That's why W2 is equal to Q1 V of R1. That is W2 is equal to work done against the electric field, against the external field, plus work done against the electric field with the charge Q1. So we know the formula, that is W work done with the external field Q2 into V of R2, plus for work done field due to the formula of force, we know the formula of force, that is 1 by 4 pi epsilon naught Q1 Q2 by R1. Potentials are not force. Potential formula we know that is 1 by 4 pi epsilon naught Q1 Q2 by R. So that's here we have taken 1 by 4 pi epsilon naught Q1 Q2 by R. So here the charge is taken, here we have from point 2 to point 1. So that's why the distance is 1, 2. So then we know the principle of superposition, that is W is equal to, we have to add both of the charges, W1 and W2. So that is W2 is equal to Q2 V of R2 plus 1 by 4 pi epsilon naught Q1 Q2 by R12. So now what is the total potential energy? So we know the formula U is equal to Q into V of R. So here two charges we have taken, that's why U is equal to first charge Q1 V of R1 plus Q2 V of R2 plus 1 by 4 pi epsilon naught Q1 Q2 by R12. So this is the formula of potential energy in a system of two charges by applying external electric field. So now you can just see the diagram. So here the uniform electric field, so we have taken two charges, charge 1 and charge 2. So by applying external field from the point infinity, okay, so the distance is R1 and the distance is R2. So point P and S is there. Why? Because system of two charges. So we'll get the final formula of potential U is equal to Q of R1, Q1 V of R1 plus Q2 V of R2 plus 1 by 4 pi epsilon naught Q1 Q2 by R12. That is the final formula of potential energy of system of two charges. So this is a problem. So a system of two charges, 7 microcoulomb and minus 2 microcoulomb, is placed at the distance minus 9 centimeter and 9 centimeter respectively in an external field. So you can see in this diagram Q1 charge from the distance I have taken minus 9 centimeter and Q2 distance 9 plus 9 centimeter with the points 0, 0, 0. So now we know the formula, that is V is equal to magnitude of E into R. So here they have given the charges Q1 and Q2. So Q1 they have given 7 into 10 power minus 6. So micro means minus 6 coulomb. Q2 micro means minus 2 into 10 power minus 6 coulomb. So now only we have studied the formula U is equal to Q1 V1 R V of R1 plus Q2 V of R2 plus 1 by 4 pi epsilon naught Q1 Q2 by R12. So now you just apply the formula, apply the see here they have given minus 9 and plus 9. So you can take minus 9 into V of R1, the distance is 9 centimeter, plus minus 2 into the distance they have given here 9 centimeter. So now just apply that formula, so we'll get the answer. So for this potential you can apply this formula, so you will get the final answer is 49.3 joules. Just take the formula and whatever they have given the values, you apply for that and explain it and solve it, you will get 49.3 joules. So the next topic is potential energy of a dipole in an external field. So here we have to take a dipole in an uniform external field. So you can observe the diagram very carefully. So this is a derivation. So you just see the diagram now. So uniform electric field. When the uniform electric field, if you are going to take, so I am going to place the dipole in an uniform electric field. So when in the last chapter we have discussed, when you place the dipole in an uniform electric field, it behaves like a torque. Okay, so you can see this, when you place a dipole on this, so it starts rotating clockwise. When it comes over here, it starts rotating anti-clockwise. So here minus Q2 plus Q. So when it starts moving, so it forms an angle theta in an electric field. So that is F force, then this is x-axis and this is y-axis. So here I have taken when it forms a theta, so it forms an triangle. Okay, that is A cos theta. So because we know that when it forms a theta, we will get two components, that is horizontal and vertical components. So when you get the horizontal and vertical components, here we will get A cos theta and minus A cos theta. Then dipole, so dipole is P vector and the distance between dipole is 2A. So this is a diagram. Then we have to come for the derivation. So F net is equal to F plus F minus. So here we know the formula of F, that is plus QE. Then F is minus QE. So we know the formula, that is F is equal to Q into E. So here plus Q and minus Q is 0. And we know the formula of torque P sin theta. So that is cross. So here cross P sin theta. So cross means sin theta into minus K vector. So we know that when the theta is 90 degree. So sin 90, you can take here sin 90 and also you can take 270 degree. Okay, so when the torque will be maximum. So why the torque will be maximum? If you are going to take, you just apply theta as 90 degree. So when theta is 90 degree, you will get 1. So then it becomes PE. So when theta is 270 degree, we will get torque is PE. Why? Because sin 90 and sin 270 is 1. So then we will get PE. Then if you are going to apply, theta is 0 degree. See here you can see, so when theta is perpendicular, so like this it will come. So when it is perpendicular, so when it is perpendicular means here we should take sin 90. So sin 90 is 0, then 190 is 0. So then the torque will be no. So then there will be a no torque. So why? Because here sin 90 and sin 180 is 0. So then this becomes, the torque becomes 0. So when the torque is maximum, when the torque is minimum, when the torque is maximum, then theta is 90 and 270 degree. When the theta is 0 degree and 180 degree, so we'll get the torque is 0. Okay, so this is the explanation. So then when the torque is applied in such manner, it will neutralize. So when it neutralize, so we have to take the anti-clockwise direction. So that time we will get torque external is equal to minus torque E. So here integral of theta naught theta 1 PE sin theta d theta. Now we have to take outside PE theta naught theta 1 sin theta d theta. Okay, so now PE write as it is. Now what is the integration of sin theta? What is the integration of sin theta? Minus cos theta. Okay, so then substitute the limits theta naught theta 1. So now substitute the limits to theta. Okay, so then we will get cos theta naught minus cos theta 1. That is PE into minus cos theta naught. So minus is there, one more minus, it will come plus. That is cos theta 1. So now just upper limit and lower limit you substitute. So I will take, so first you have to take, when you are going to substitute after the integration, so you have to take upper limits. That's why I will take this side. So that it becomes PE cos theta 1 cos theta naught minus cos theta 1. After substitution, you can write PE cos theta naught minus cos theta 1. So I can write this as potential, that is U into theta 1 minus U into theta naught. So here we have applied already, we know that, so we'll 90 degree, so we'll get perpendicular 90 degree. So that's why here I have taken pi by 2. Theta naught is pi by 2 and theta 1 is 0 degree. So when we are going to substitute theta naught is pi by 2 means cos 90. So cos 90 minus cos here 0. So when you have cos theta. Okay, so now if you are going to apply cos 90, so it will becomes 0. So when it becomes 0, we'll get cos theta as it is, you write. So U of theta is equal to PE into minus cos theta. So the final expression is, so when you are going to take this, so it becomes 1. Cos 0 is 1. So now U of theta is equal to, it becomes minus PE. So this is the final expression. So here you can see one numerical problem. So a molecule of a substance has a permanent electric dipole moment of a magnitude 10 power minus 29 coulomb meter. A mole of this substance is polarized. So by applying a strong electrostatic field of magnitude 10 power 6. So in this question they have given these things, dipole moment they have given 10 power minus 29 coulomb meter, and a mole of a substance, that is we know already 6 into 10 power 23 molecules, and so the total dipole moment, so just multiply both of that, 6 into 10 power 23 into 10 power minus 29. So I'll get minus 29 plus 23 will get minus 6. So that is 6 into 10 power minus 6 coulomb meter. So now we know the formula of potential when it is applying on an external field on a dipole. So that is U is equal to minus PE cos theta. So Ui is equal to minus PE cos theta. So here we know now only we found P value is minus 6. In the formula minus 6 is there. So 6 into 10 power minus 6 into, so cos theta they have given 0. So in the question they have given that is cos 0. So cos 0 is 1, we know that. So that's why that formula 10 power minus 6, 10 power plus 6 is gets cancelled. Then it becomes 1. So then Ui is minus 6 joules. So when theta is 60 degree, so when theta is 60 degree, so you just apply minus 6, say minus 6 into 10 power minus 6 into 10 power 6, so cos 60. So I will get minus 3 joules. So now we know that UF and UI. So that is UF minus UI is equal to minus 6j minus 3j. So we will get plus 3j. After substitution we will get plus 3j. So you can see here we are getting the value plus 3 joules. So that's why the potential energy will release in the form of heat. And so this is an example of U, potential energy when you place electric dipole. When you place electric dipole in an uniform electric field, so you will get this formula. So that is Ui is equal to minus PE cos theta.